What's up, y'all? Today I'm doing Openkeys from HackTheBox. This was a medium-rated BSD box, and we start this box off with nmap, and we find there's a web server running. When we go to check it out, we just see a login page and nothing else really. So we run ffuf against it, and we find an includes directory that has the source code for the page that we're trying to log in against, and we find out the author of that file. We use that in combination with the CVE that we locate from within the source code, and we're able to bypass the login page, and this gets us an SSH key. And for root, we exploit a privilege escalation vulnerability in BSD 6.6. So let's get started. We start this box off with nmap, sv, sc, oa, put it in the nmap directory and call it Openkeys, and the IP address is 10.10.10.199. I've already run this, so let's take a look at the output. And we see there's only two ports open. We have SSH on 22 and HTTP on port 80, and we see it's running OpenBSD. So let's check this out in Firefox. And we just see a login page. So if we try to log in with admin, or try to throw admin and a single quote to see if maybe there's a SQL injection, we just get authentication denied. So we'll default to enumeration and try using ffuf against this. And we'll just use out of seclist discovery web content common. And we'll let this run. We have a bunch of stuff come back, a bunch of 301 redirects. The most interesting one is includes. So let's check that out. Includes. And we see an auth.php and an auth.php.swp. If we check out auth.php, it executes, so we don't really see anything. If we go to the swap, we can see the swap. Right at the top, we see Jennifer and Openkeys, so this is potentially a username. So we head over here and just open up some notes. The potential username is Jennifer. And we have auth.php. So we can grab this and recover the file. And we'll save it as auth.php.swap. And we can do vim-r, auth.php.swap. Perfect. So we can see this is a file that maybe we're trying to authenticate against. And it looks like it's running escape shell cmd, auth helpers, check auth. So we'll save this as auth.php. And just looking through this, we can just see if there's any known vulnerabilities with check auth and BSD. BSD vulnerabilities. And it looks like there is. It looks like there's an authentication bypass and local privesc. So if we wanted to look at authentication bypass, CVE-2019, it looks like there's an auth bypass, and it pretty much, we read through this, it just says, using this flaw, a remote attacker can successfully access vulnerable services with any password by just entering the username as schallenge. So if we head over here and try to log in, we can try entering schallenge as the username. Schallenge. And just 1234 is the password. Try to log in. And it says open SSH key not found for user schallenge. So it looks like we're definitely able to bypass the login. So if we try to capture this request in burp, oh, and also it looks like it's forwarding us to, let's just look at that again, sshkey.php. And if we look at the title, it says retrieve your open SSH keys. So maybe we need a user, we need to figure out how to add a user to this. So if we intercept the request with burp, try to log in, send this to repeater. We can just try adding username as another parameter, as Jennifer, and see if this works. and it says authentication denied. If we try it at the beginning, and it looks like we get a redirect. So if we follow the redirection, it says open SSH key not found for user schallenge, so that didn't work either. We can try specifying this as a cookie and sending this through, and we get another redirect, and when we follow it, it looks like we got in as Jennifer, and this is the SSH key. So I'll just request this in the browser, or show this response in the browser. And we've got the key, open SSH key for user Jennifer. So I'll copy this, and we'll just say jennifer.key. chmod 600, so we can use it. And we'll SSH -i for the key we want to use. Jennifer at 10.10.10.199. And we're in. Who am I? Jennifer. Can we read user.text? We sure can. So now we need to look into how to escalate to root. From earlier, we saw there were a few local privilege escalation vulnerabilities that were released around the same time as the exploit that we just used to bypass, so maybe this is also vulnerable. So if we look at the local privilege escalation, it looks like Qualysys researchers have also released a proof of concept. And this is in OpenBSD. So if we kind of scroll down, SSH, SU, local privilege, and xclock. So on OpenBSD, xclock is installed by default and is set group ID auth and not set user ID. So it looks like this user that starts off is in just the nobody group, and at the end they are in auth, but we want to get to root. So if we read privilege escalation via skey and YubiKey, we see that this user that is a member of the auth group can run this, and this, and eventually they will wind up at root. And this is if skey is enabled, a local attacker with auth privileges can add an skey entry for the user root. And we wind up with the root shell. So let's see if we can exploit this. So I'll move this over here. So first we need to see if we're a member of the auth group, which we're not. We are a member of the wheel group though. So if we go into temp, we can just copy this proof of concept, compile it, run this, and run this, and ID, and we are now officially a member of the auth group. So from here we can just kind of follow this next one, where we add this to skey root, chmod it, run this, and it looks like this is a password entry. And who am I? We're root, and the hostname is Openkeys, and we can read root.text. So this box was pretty straightforward. I hope you enjoyed the video, and I'll catch you next time.